Hello students.
So how to represent the organic compounds in different manner. How can you represent the structural representation? One is bond line notation. Suppose one compound is given to you whose molecular formula is 𝗕3H8. First of all, you know that the general formula of alkenes. See here. Tell me, what is the general formula of alkane? If I write the alkenes, the general formula is CnH2n plus 2. Okay. If it is alkene, ENE, then the general formula is CnH2n. And if it is alkyne, YNE, the general formula is CnH2n minus 2. Okay. So see here, if 𝗕3H8, that means it's this is an example of a compound having general formula alkane. Satisfy the general formula of alkane, 𝗕3H8. 3 2 is 6 plus 2 8. So 𝗕3H8 is a saturated hydrocarbon alkane having carbon number 3. Means how can you represent the structurally? It is 3 carbon atoms. So first of all, write the 3 carbon with skeleton. And how many hydrogens are there? Satisfy the hydrogens. See here, 1 2 3, here also 1 2, here 1 2 3. See here, 𝗕3H8. So this is a structural representation. Now how can you write the bond line notation? In bond line notation, remember, always the carbons are present at each corner. How many carbons are there? 3 carbons. So if I write the 1 carbon atom, another carbon atom, this one. So in each terminal as well as in corner there is a carbon atom. This is 1 carbon atom, this is 1 carbon atom, this is another carbon atom, this is another carbon atom. So again, already this can be satisfied. Don't show the hydrogens in the bond line notation. It by default it will shows the satisfaction of hydrogens along with the carbons. So this is the bond line notation of what? This compound. Similarly, C4H8. Okay, C4H8. What is the general formula? C4, 4 2 is 8. That means it must be an alkene. Alkene means there is a presence of double bond. Alkenes presence of single bond. Alkynes means presence of triple bond. So there must be presence of double bond, C4H8. First of all, how many carbons are there? 4 carbon atoms. Okay, first write down the carbon. 1 2 3 4. Okay, and in alkenes means any one position there is a double bond. So the double bond. Now you satisfy this with hydrogen. If it is a double bond, then it requires how many bonds to satisfy? Another 2 bonds. So I will put 2 hydrogens here. Here 2 plus 1 3. 3 bonds means another 1 hydrogen. Here 2 bonds means another 2 hydrogen. Here another 3 hydrogen. Okay. So this is the structural representation. Now how can you write the bond line notation? Again, how many carbon atoms are there? 4 carbon atoms. So I will represent this as 1 2 3 4. Okay. Here 1 carbon, 2 carbon, 3 carbon and 4 carbon. Now in first and second carbon, in between first and second carbon, there is a double bond. So if this one is a first and second carbon, so there is a double bond. Okay. So this is the bond line notation of this compound. Similarly, see here, C5H8. C5H8 means the general formula becomes, see here, C5 2 is 10 minus 2. That means it must be alkyne. Alkyne means it must be a presence of a triple bond. So first of all, write the number of carbon atoms here. If I write 1 2 3 4 5. Okay, so that means there is a presence of a triple bond. If I write 1 2, you can write different structures. Here I यहाँ पे मैंने यहाँ पे पुट किया डबल बॉन्ड. आप चाहो तो वहाँ पे पुट कर सकते हो. यहाँ पे फर्स्ट पुट कर सकते हो, सेकंड में कर सकते हो, थर्ड में कर, आपकी मर्जी. ओनली टू शो द प्रेजेंस ऑफ ए डबल एंड ट्रिपल बॉन्ड एंड टू शो द बॉन्ड लाइन नोटेशन. यहाँ पे हम कुछ एग्जांपल्स लिए हैं. ओके, सो सी हियर, if I put a triple bond here, this carbon requires another 1 bond, that means 1 hydrogen. Here there is no bond is required, 3 1 4 already satisfied. Similarly, now this carbon becomes, here it requires 2 hydrogen. Okay, here this also requires 2 hydrogen, and here this carbon requires 3 hydrogen. 1 2 3. Okay, so now how will you show the bond line notation? How many 5 carbon atom? So if I write 1 2 3 4 5. Okay, now here 5. So that means in first and second carbon atom in between there is a triple bond. So is the triple bond. This one is the triple bond. Okay, triple bond. So this is the bond line notation 1 2 3 4 5. Similarly, another compound in which there is a functional group. So here another oxygen is there, C8H18O. Okay, so first of all we will draw the skeleton. 1 2 3 4 5 6 7 8 carbon atoms are there. Okay, and one oxygen is there. Suppose if I put one oxygen here, oxygen, again we know that oxygen is divalent, so oxygen is satisfied with a hydrogen OH, right? Now you satisfy all these along with hydrogen. Okay, suppose this one is your C3 hydrogen because 3 1 4. Again this requires 2 hydrogen, this requires 2 hydrogen, this is 1 2 3 means requires 1 hydrogen, here also 2, here also 2, here also 2, here also 3. Total count 3 to 5 to 7 1 8 1 9 to 11 to 13 to 15 3 18. So it satisfies C8H18O. Okay, now how can you represent the general, that means bond line notation of this compound? 8 carbon atoms. So first of all I will represent this H. 1 2 3 4 5 6 7 8. See here. Now 1, this is 1 carbon, 2 carbon, okay, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7 carbon, 8 carbon, right? So 8 carbons are there. Now in which position there is a OH group? If it is your position, you can show the position. 1 2 3 4 5 6 7 8. So in 4 position there is a OH group. So see here, here also 1 2 3 4. In 4 position there is a OH group. Okay, so this is the bond line notation of this compound. Okay, thank you. Hello students, now today we will discuss about the classification of organic compounds. See here, this is the classification of organic compounds. First of all, organic compound is divided into 2 types. One is acyclic, another one is cyclic. Again, acyclic compound divided into 2 types. One is saturated, another one is unsaturated. A saturated के अंदर कौन सा आता है? That is your alkanes are only your saturated compounds, and unsaturated there are 2 types. One is alkenes and another one is alkynes. Now saturated alkanes means all the single carbon-carbon single bonded compounds, they are considered as alkanes. Alkenes, in between carbon and carbon there is the presence of double bond, and in alkynes there is carbon-carbon triple bond. Okay. Similarly, cyclic compound is divided into 2 types. One is homocyclic, another one is heterocyclic. And homocyclic again divided into 2 types, alicyclic and aromatic. Alicyclic means cycloalkanes, cycloalkenes or cycloalkynes. Similarly, aromatic can be divided into benzenoid compounds and non-benzenoid compounds. Now we will discuss all about the compounds by taking some examples. See here. Now first of all, alkanes. We know that alkanes, in between carbon and carbon there is a single bond. So these are saturated hydrocarbons. So alkanes can be of 2 types. One is straight chain alkanes, another is branch chain alkanes. We can take different examples. Suppose if I will take example of straight chain alkane. Suppose this is your straight chain, okay, and if I satisfy 3 2 2, this is a straight chain compound, and this is the N-butane. That is N stands for normal, N-butane. Similarly, what is a branch chain? Branch chain you can write, this is your branch chain, 1 2 3. Okay, this is a branch chain. Satisfy this, CH3 CH3 CH3. Okay, now this compound is this is a neopentane. Neopentane, these are the common names. This is a neopentane, 5 carbon atoms cell. This is neopentane. This is the branch chain compound, this is the straight chain compound. Similarly, unsaturated hydrocarbons are divided into 2 types, alkenes and alkynes. You can take any example. If I'll take C, there is a double bond. Okay, now this is 3. Here 1 2 3 means 1 hydrogen. Here 2. So what is the name? 1 2 3. It is your propene. Okay. Similarly, alkynes. Take any of the example. CH triple bond CH. Okay, this is your ethyne, or I can take acetylene. The common name is acetylene. So this is the alkyne. Triple bond is the alkene, double bond is there. Similarly, homocyclic or carbocyclic. These are the 2 compounds. One is alicyclic compound and the aromatic compounds. Which compounds are known as your alicyclic compounds? Now normally the compounds which that means is a homocyclic compound cyclic. Cyclic word means what? Cyclic word means it is a ring compound which is made up of carbon only. That is why it is called homocyclic. It comes under homocyclic or carboxylic. Now 𝗕cyclic meaning 𝗕cyclic means 𝗕 means aliphatic, cyclic means closed chain. That means the aliphatic closed chain compounds comes under 𝗕cyclic compounds. For example, if I will write the compound, this is your what? How many carbon atoms are there? 1, 2, 3. So it is your cyclopropane. Okay. Similarly, if you take another example, you can take this one. How many carbon? 1, 2, 3, 4, 5, 6. So it is your cyclohexane. That means it is a cyclic compound in which each corner there is only presence of carbon atom. So this is your aliphatic cyclic compounds. Okay. There may be a 3-member, there may be 6-member, there may be 5-member, cyclobutane, cyclopentane, they all comes under alicyclic compound. Similarly, aromatic compounds are divided to benzenoid compounds and non-benzenoid compounds. Which compounds are benzenoid and non-benzenoid compounds? See here. Now, benzenoid compounds means, first of all, we will take the example of benzene. Okay. This is the example of what? Benzene. This is a benzenoid compound. Similarly, if I will write the compound, this is the name of the compound is toluene. So this is also a monocyclic compound. This is also a benzenoid compound. Similarly, if two rings are fused with each other and they also form a benzenoid compound, like, and this is known as naphthalene. This is a benzenoid compounds. So these are the different examples of benzenoid compounds. Similarly, non-benzenoid compounds. Which compounds are known as your non-benzenoid compounds? Now normally the compounds which doesn't satisfy the Huckel's rule. The compounds which satisfy the Huckel's rule, that we will discuss later. Huckel's rule, that are benzenoid compounds. The compounds which does not satisfy the Huckel's rule, they are only non-benzenoid compounds. For example, in non-benzenoid compounds, you can take example of okay. So how many carbon atoms are there? 1, 2, 3, 4, 5, 6, 7 carbon atoms with a double bond O. And the name of the compound is tropolone. Okay, this is a non-benzenoid compound. Similarly, other examples are also there. Now, heterocyclic compounds. Which compounds come under heterocyclic compounds? The compounds in which that means this compounds is a closed chain compound and having a heteroatom at one or more corners. Okay, heteroatom means other than the carbon atom, that may be oxygen, that may be sulfur, that may be nitrogen. Okay. Now see here, in this case, if I write the alicyclic compounds, suppose the first compound, the one example of alicyclic compound where oxygen is in the center, the name of the compound is oxirane. Okay, this is a oxirane. Similarly, another solvent, that is the tetrahydrofuran. Okay, see how many carbon atoms are there? 1, 2, 3, 4. Okay, so the name of the compound is tetrahydrofuran. Tetrahydrofuran. That is your THF. So this is an example of tetrahydrofuran, and this is oxirane. Similarly, aromatic compounds that which are heterocyclic, that means they obey the Huckel's rule. Okay, along with the sum of one or more heteroatoms present in one of the corner. Suppose for example is furan. If I will write the structure of furan. Okay, furan. This is an aromatic compound and this is a heterocyclic compound. Similarly, you can write pyrrole also. Okay, this is PY. Okay, so these are the aromatic compounds having in one corner there are presence of heteroatoms. So heterocyclic aromatic compounds. Okay.